Hi, Mr. Wright here, and welcome to this set of IGCSE exam questions, which are about grades 6 to 8. So these sets of questions are perfect if you're approaching your exams and you want to practice questions on a range of topics, all at a certain level. So hit the link in the description, download the questions, have a go, and then watch my worked solutions. If you find this film useful, please hit like, and if you have any questions, of course, leave them in the comments and I'll respond. Good luck.
Function g and h are defined as follows. Find the value of g of 1. So we're going to use the input 1, see what that does to, when it's g'd, we're going to g1. Gives me 1 over 2 minus 5, which is 1 over minus 3, which is minus 1/3. Good. State which value of x must be excluded from any domain of g. Well, we can't have a denominator of 0. So the value of x which must be excluded is the value which makes the denominator 0. So it's 5 over 2. Find g of h of x. Okay, well, h of x is x plus 4. So g of h plus x is the g of x plus 4, which is going to be x plus 4 over 2 lots of x plus 4 minus 5. Okay, which is x plus 4 over 2x plus 8 minus 5, which is x plus 4 over 2x plus 3. Right, express the inverse function, g minus 1, in the form g to the minus 1 of x. Okay, so g of x is x over 2x minus 5. So I'm going to write that as y equals x over 2x minus 5, and I'm going to make x the subject. I'm going to multiply both sides by 2x minus 5. I'm going to multiply out that bracket, 2xy minus 5y equals x. I'm making x the subject, so I'm going to put all my x's on the left-hand side, minus x from both sides, and then plus 5y to both sides. Now I'm going to factorize the left-hand side. 2y minus 1 equals 5y, and now I'm going to divide. So x will be 5y over 2y minus 1, which means that the inverse function is 5x over 2x minus 1. Okay, there is question 1 sorted. Right, we've got two chords of a circle, so this is likely to be the intersecting chords theorem. I've got to work out the value of x, which is here. Okay, so using the intersecting chords theorem, 8 times x equals 6 times 6.5. So 8 times x is 6 times 6.5 is 39. So x is 39 divided by 8, 4.875 centimeters. The size of each interior angle of a regular polygon with n sides is 140. Work out the size of each interior angle of a regular polygon with 2 n sides. Okay, let's concentrate on the first regular polygon here. It's got an interior angle of 140, so its exterior angle is 40, so its number of sides is 360 divided by 40. It's a 9-sided polygon. Great. Right, now let's have a think about the second regular polygon in the question. It's got 2 n sides, so its number of sides is going to be 18. We're asked to find its interior angle. Well, that's going to be 180 minus the exterior angle, which is going to be 360 divided by 18. So that's 180 minus 20. So this polygon's interior angle is 160 degrees. Okay, that is number 4. We've got a cuboid here with a volume of V. It's got a length of y and a width of x and a height of x. The width and height of the cuboid, fine. The total length of all the edges is 112. Show that V equals 28x squared minus 2x cubed. Well, let's start by using this fact that we're given here, that the total length of all the edges, which is going to be 4y plus 8x, is 112. I've also got an equation for the volume of the cuboid, haven't I? The volume of the cuboid is going to be y times x squared. Now, I've got to form an expression for the volume in terms of x only. So what I'm going to do is I'm going to use this equation, equation 1, to write an expression or derive an expression for y. And then I'm going to substitute that expression for y into the equation 2. So I've rearranged equation 1 to give me y equals 28 minus 2x. And equation 2 is that the volume is v times x squared. Sorry, y times x squared. So the volume is 28 minus 2x multiplied by x squared, which is 28x squared minus 2x cubed, which does match what I was asked to show. So that's part A done. Part B, find dv by dt. So I'm going to differentiate my expression for v with respect to x. Clearly the volume changes as x changes, doesn't it? So that's going to be 56x minus 6x squared. So there is my differential. There we go. Find the maximum value of v. Well, the maximum value is going to occur when dv by dx equals 0. So I need to solve this equation to find the maximum, to find the x that gives me the maximum volume. So solving that equation, let's have a look. I can divide all the way through by x, which will give me 56 minus 6x equals 0. So 6x equals 56. So x is 56 over 6, which simplifies to 28 over 3. So x is 28 thirds. And now I need to find the volume, don't I? Now the volume will be 28x squared minus 2x cubed. So that's going to be 28 times 28 over 3 squared minus twice 28 over 3 cubed. So a bit of calculator action now. So I've got 28 times, open bracket, fraction 28 over 3, close the bracket, squared, minus 2 times, open the bracket, fraction 28 over 3, close the bracket, cubed, which gives me a volume to 3 significant figures of 813 centimeters. And there is my solution to question 3. Right, I've got a sector of a circle with a center O, so clearly with a radius of 6. I'm told the area of the sector, so that'll be useful, and I'm asked to calculate the perimeter of the shaded segment correct to 3 significant figures. Okay, well, to start off with, let's find this angle here, the angle alpha. I know that alpha over 360, that fraction of the area of the circle is 5 pi. So I'm going to substitute in my r is 6, and I'm going to divide both sides by pi as well to give me that. That means that 1/10 of alpha is 5, so alpha is 50. So we know that that top angle is 50. Now, let's draw the triangle AOB. That's 50. These two sides are 6. I'm going to call the length AB, which I need to find the perimeter of the shaded section. I'm going to call that A. And now I'm going to use the cosine rule to find the length of A. So A squared equals B squared plus C squared minus 2BC cos 50. Right, so into my calculator goes. 6 squared plus 6 squared is 72 minus 2 times 36 times cos 50. That gives me an A squared of about 25.7 and so on. And so A is the square root of that, which is 5.07141 and so on. Okay. Now I need to find the perimeter of the shaded section. So I found the length AB, 5.07. So I need to find the length of that part of the circumference, AB, don't I? So that's going to be a certain fraction of the circumference, isn't it? So the AB is going to be 50 over 360 times the circumference of the circle, pi d, so pi times 12. So a bit more calculator action here. I'm going to have 5 over 36 times pi times 12. So that gives me 5.23598 and so on. And onto that, I'm going to add my length of little a, the length of that chord there, plus 5.07141. And that gives me the total length of the perimeter, which I'm going to write to 3 significant figures. 10.3 centimeters to 3 significant figures. And there is my solution for question 5.